And a few things that I've noticed is that we'll just call this a typical, scenario in the Bay Area was there was some kind of chaos, around the company. And this has happened in many different companies that I was hired as an engineering manager. And I even would go so far as to say, if somebody offers you, a CTO position or head of engineering position or some kind of position, it's actually not necessarily what you would expect, in that oftentimes the reason that position is available is something is terribly wrong. And that's been my experience, is that every time I got hired as an engineering manager, it was because something was really messed up bad. And I've had this chaos scenario happen in game studios, and I've also had it happen in software as a service companies, where we had paying customers on a monthly basis. And I've also had it happen in film. And I've also had it happen in social media. So I ran a social media company for a while. And in every situation, really at the core was the same problem. And at the core of the problem is that there was a lack of automation. So we'll say this is the problem was over here, and then the solution is on this side, and then the solution really was this lack of automation solving it. And it's amazing how this becomes really the fix for a lot of problems in software companies. And once you fix the automation part of the problem, you can fix the rest of the company. And I think more and more, I think people are getting to realize that what that really means is DevOps. So to me, DevOps really means that you're going to fix this feedback loop where your company has, let's say, a list of ails. Like, for example, if we get into the maybe more of the characteristics or the symptoms, we'll just say symptoms right here. Symptoms. The symptoms of this would be that late delivery would be a symptom. Also, quality. The quality is really bad. These are all reasons why you need to implement DevOps and why you want to get automation. So let me just dive into a little bit more of the actual solution here. That's really setting the stage for the problem to some degree. But really at the heart of things is this CD pipeline. And at the middle of this CD pipeline, or continuous delivery, let's just go through here, continuous delivery, like this, is this idea that on a daily basis, or even multi-day basis, you're improving the quality. And that's really at the heart of why you would want to do continuous integration. And it's a lot like the human body or your bank account, or whatever analogy you want to pick, is really there's three states. And state number one is worse. Number two is the same. And number three is better. And really those are your choices on a daily basis in a software product. And you're either getting worse, you're the same, or you're better. If you don't know which one is happening, you're probably getting worse, as just a rule of thumb here. And so when you're building software, if you're not thinking through this process of how do I make things better, that's how I've seen problems develop. And there's a word for this, and it comes from the Japanese automobile industry, and it stands for Kaizen. And Kaizen in Japanese literally means improvement. And that's really the whole idea behind continuous delivery, is that you're testing your code, you're testing you're testing the code, you're testing the infrastructure as well, and you're also delivering releases to the client so that the client can give you feedback. And so this is just a constant feedback loop, and you're with this Kaizen type approach is you're improving. And so in the examples where I've worked for companies that had big problems, they weren't doing this. So there would be a delivery every month, for example, and the software was of poor quality, and they were building something where the customers never saw the code. And so really this is the death spiral when you see that in an organization, is that it's your goal to as a person that's implementing testing is to get this feedback loop. And this really is at the heart and soul of most problems that I've solved in a corporation. Is you got to tighten up the feedback loop, get multi-day releases if possible, and also keep improving things by adding the appropriate level of tests. Not going too crazy where you're burdening your team with a bunch of brittle tests, but key functional tests that allow you to kind of get into some of the characteristics of improving your software. So let's talk about some of the details of a Python project that you could build that would improve things. So I call this the Python scaffolding approach. And this is how I typically build out most products. And what I do is that I have at the start here, let's just call this a Git repo. And we'll go ahead and build this. But here's a GitHub repo. And I like to create a makefile. And the makefile will essentially have all the commands that I need. So it will have an installation. It'll have a lint step, which will check for syntax errors. I'll have a test step. I could have a format step. And then I also could go through here and do a deploy step as well. So to me, the makefile actually simplifies things if you include it in your project, because this makefile also can be called by the CI/CD system. So locally, I can use the makefile, and I also can easily do the same steps. So for me, it's a great way to simplify my project. Also, we'll put a requirements file here, typically requirements, and then I'll also have whatever the script. So we'll just say hello, and then maybe like a test file, and that's really the basic structure of what I would call like a scaffolding, where if you build this structure out every single time, my opinion is that it really does make things a lot simpler in setting up CI/CD. And let me also talk a little bit about some of the different technologies that are available with CI/CD and what we're going to get into in a second. So in terms of CI/CD technology, I think that really the one of the dominant ones, and it's appropriate to talk about it now because there's GitHub Universe, really is I think GitHub Actions is probably the best game in town right now for continuous integration, just at a consumer level. There are some cloud native solutions that are pretty nice, but let's talk about some of the things that are nice about GitHub Actions. One of the things that's nice about it is that because you have this integration into GitHub, most people are already using GitHub. It's pretty easy to create mini actions. So you could test, for example, Python 3.5. You could test Python 3.6, right? You could test all these different ones. And even further, what's nice about it is that with GitHub, you can also use something called Codespaces, which again, I'll get into in a second. And with Codespaces, you can actually just run in the same environment. So from like a testing standpoint, in my opinion, this is probably as good as it gets in terms of just speed. But I also wanted to talk a little bit about, and again, we'll get into this in just a second, but I also want to talk a little bit about the cloud native CD systems. So in a CD pipeline, really CD stands for continuous delivery, and with continuous delivery, the idea is that the code is always in a deliverable state. It doesn't necessarily mean you're pushing it on a pull request to production, but what it means is you could, if you wanted to, is that everything is basically in place. There may be business reasons to not do this, but in terms of the cloud native, my opinion is if you are on a cloud, that probably it's a good idea to use the cloud native continuous delivery system. So on AWS, for example, they have something called Code Build, and I think we'll have time to go into that. GCP has something called Cloud Build, and then Azure has something called DevOps pipelines. And in each case, what's nice about these services is that they are directly integrated into the cloud environment. And so some of the things that come up that are annoying, for example, dealing with role-based privileges, you can solve that by using the cloud native provider. So, I think this is really something to think about, as well as maybe there's two components to testing your project. The developer component, where you want all the fancy bells and whistles. Maybe you do that with GitHub Actions. But then when you get to the deployment part of it, I think there's a lot to like about using the native cloud tools because of just the deep integration. So what we're going to do then is set up a general structure that allows us to test out a command line tool. So let me just walk through what that would look like. And so to start with here, what we're going to create first is a CLI project that we can build from scratch, and we'll create the basic structure, and then we'll also test it, and then we'll be able to run it on multiple clouds. And I think that will be a good, fairly ambitious thing to cover in the next hour and 45 minutes or so. So let's go ahead and get into the code itself and get into the hands-on stuff. So what I'm gonna do next here is share something that I built previously that will probably be a good just reference here. Let's see. I'm gonna rebuild some of this here. I'll put this into a chat message here. Okay, here we go. Okay, so I'm going to build something kind of similar to this. So what I will do is I'm going to start out with creating a new repo. So first step, let's go ahead and do that. Say new repo, and we'll call this CLI multi-cloud DevOps. All right, and this will test a command line tool on multiple clouds using DevOps best practices. Okay, so what I would typically do is do a README here. I would also add a gitignore file and go through here and add Python. Perfect. And here we go. Let's go ahead and do that. Okay, so now that I've got this project set up here, what I'm going to do to run it is I'm going to use a beta tool that I believe will be out shortly, if you notice here, I have access to something called Codespaces. Really, it's similar to cloud environments, but I'll show how I can also do the same thing in a cloud environment. So I'm going to click on Codespaces here, and I think I will just get rid of this one real quick, and I'll make a new one. So I'll say new Codespace, delete this. And I'm going to choose that repo I just created, which I called it, was it CLI something? I'll have to actually find my own repo here that I just created. Okay, it is called CLI Multi DevOps. Okay, we'll just copy that name. Okay. There we go. And I'm going to create this code space. So all this is a cloud-based web or a web-based development environment that we can build out the scaffolding. And it's similar, in fact, to AWS Cloud 9. I would say it's kind of similar, and it's also similar to Azure Shell and also Google Cloud Shell. So we will actually use 4 different development environments, and I'll show you how they all can play nice with each other. So let's go here, make this a little bit bigger. Okay, so we got this basic structure here. And as I mentioned, what I typically do is create that scaffolding structure first. And even before that, I'll create a virtual environment. So if I go through here and I say Python 3, or actually I say virtual environment, virtual env, and I say Python tilde CLI multi-cloud. Let's go ahead and do that. And I'll go ahead and source this. And now if I type in which Python, and I type in Python, we got Python 3.8. Okay, so this just gives me a sandboxed environment. In fact, I'll just read this here. I'll just put these commands inside the README and just say, do this if you're inside this project. So we'll say setup here, and
okay.
I would do that.
So what's the setup?
And then I would put in a source here. Let's go ahead and do this. Okay, so I've got the first part of the project here would be the setup. Got it. Now the next thing I would do is create a makefile. So go ahead and do that. We'll create a hello, and we'll also create a test hello.py, and then also a requirements file. So this is typically what I would do, just because it's a nice repeatable process that's fairly easy to do on every single project. And inside of here, I can actually just copy what I did earlier. Typically, I use the same style for most projects, so I can easily go through here and just do the same thing. I can go to this makefile and just add these commands in. And let's just look at them real quick. So installation, this upgrades the pip install tool and also looks inside of requirements. The lint will just lint my code. And notice I disable the R and the C, which are annoying warnings for PyLint. If you wanted to swap this out with some other linter like PyFlake or another linter, I think there's other ones as well, it doesn't matter. You can just swap this out because it's abstracted with the word lint. Also, this is a code formatter, and then this is a test. And then later, if you wanted to go to the continuous deploy aspect of it, right, you could say deploy here, and then you could say echo CD, right? And you just swap that out with whatever cloud environment or target that you're going to deploy to. So that looks like that's pretty good. And let me also then go back to this, and I'll put in the requirements file. So the requirements file here, if I look at this, this should have all the packages that I need. So let's go through here. There we go. And then in terms of a hello world, I'll also just build that out real quick. I have a hello world file here that does this, which is really a very basic command line tool. And so let's go ahead and throw that in there. And this will be my hello script. Okay. Perfect. And then the other thing I can do is put this test file in there as well. Okay, so got all this stuff set up. Pretty easy to get a scaffolding. I mean, I guess in theory, I know some people have asked me, build this into like a Python tool that you could pip install, which is probably not a bad idea. But I would say this would be like step one, right? Is just pump this out into your project, because once you do this, we can easily test everything, right? So we've got a really basic command line tool here that all it does is look for things in your path. You know, it can find a pattern. So it's almost like an exercise in getting your code working. And then I also have the test for it, and you can see that I invoke that test here by putting those parameters in. So I've got a full working application. And if I type in make install, this will install everything in the requirements file. And then from here, now that it's installed, I can just say make lint, right? I can say make lint, and the linting works, and I can say make test, and the test works, including test coverage. So we're in good shape, and I can start building on this. Now, the thing that's missing here is that we have local testing working, but we need to set up continuous integration. So we need to get the build server working. And so what I'm going to do is I'm going to go to here, and I'm going to go back to my project, and I'm going to set up GitHub Actions. So let's go to my repositories, go to this last project, and let's click on this Actions button right here. So this GitHub Actions, why I like it is that I mentioned if you're a pure developer, and especially if you're an open source developer, I think this is the best product right now. And if you look at it, it does a lot of stuff beyond just doing continuous integration. So you can deploy applications using integrations like Node to Azure, deploy to ECS, build containers that go to Google Kubernetes engine, test other languages. Just there's tons and tons of stuff here that you can do that are pretty awesome. But what I'm going to do is I'm going to set up a workflow for myself, and I'm going to just briefly look at the documentation for GitHub Actions here. So let me actually put this documentation into my README file. Let's go to the README file and say, notes on GitHub Actions. Let's say, read about Python versions here, for example. And what this does is it shows you some information about what's available. Make this a little bit bigger, maybe a little bit bigger. What's available. So if we look at this example here, they show you that this is the different ways that you could actually test the application. So this is similar to what I'll set up is that in this particular example, it says GitHub provides a Python workflow template that can be used for most Python projects. To get started, you could put this inside of there and notice that you could actually build something like this where it actually will go through and run a matrix of tests for you automatically. And you could, again, do different levels of testing all automatically. Now, you also could specify in particular a specific Python version as well. So, but if you wanted to use multiple Python versions, I think this is a pretty good strategy here, which is what we'll do. Or you could just specifically do different things for different versions of Python, which I think could be helpful if you're going to do some really exotic things, if you're maybe a core developer of some open source library or something like that. But let's actually tweak this one a little bit. So I'm going to just copy this, and what I will do is put this one into my GitHub Actions here. So I'll just kind of paste this in here, and it is actually useful to read the documentation because you can learn a lot of stuff. So in this example, we don't want to use Python 2.7 because that won't work. And inside of here, I believe we can support, let me just look at my code real quick and we can see, do I use any F strings here? I do use F strings, so I can't support Python 3.5. So I would have to go back to this and take out Python 3.5. Maybe we could do some other kind of a test for Python 3.5. And then this looks like it works. And so that's pretty useful, right? Because I can just copy all of their stuff here. But what I can do after this is actually is put the rest of the stuff in that I typically would do. So I'm gonna go back here to my other GitHub Actions, and I'm gonna tweak a few settings. So I'm gonna look at what I've done in a previous project, and what I will do is just grab this stuff here. So I'm gonna basically grab that last section, which are all the things I did locally, right? Which are are doing these. So we'll say with. And let's go ahead and put this into this actions file. So you can see here that all we're missing is just this line here that says name, and I'll put this name inside. That will be like this, and we'll say install packages. Or actually, I guess I already had that. The formatting was off. So I can just do this here and then just tab this over. There we go. So essentially, what's clean about this is that we're able to, and maybe I'll just kind of take these spaces out so we can see more of it at the same time. But we have an Ubuntu version of our GitHub Actions, the latest version of Ubuntu, and we're doing a test matrix where it's going to test Python 3.6, 3.7, and 3.8. And with each one, it will also print out what the version is, so I can see beforehand what version of the system is running. And in fact, once we get this running, it'll also show that there's other things that you could put inside of there, but then we're going to go through and do an installation, lint, and test on all of these and see what happens. So let's go ahead and commit this. We'll say commit, and there will be a problem. I believe it'll fail initially because there's nothing in the repo yet, right? So if we go back here, this should completely blow up because there's no code in here, right? So we did the GitHub Actions, and look, it triggers 3 concurrent builds, which is pretty cool. But each one of those will blow up, right? Because there's no code. Okay, so it fails at the dependency step. So what's nice about this is that pretty easy to fix. I just go back to my GitHub, my Codespace here, right? And if I say get status, right, we can see all those files are here. But first I'm going to do a pull, right, because I pushed some files remote. There we go. We got those files remote here. And then if I say get status, I can say get add here. and then do a git commit and say checking in scaffolding, and then do a push. There we go. So we got this thing working, and if I go back now to my GitHub Actions, we can see that there should be another few runs working. There we go, and they all are running concurrently. So honestly, I think this is pretty awesome that it supports this feature, and it's trivial to test multiple versions of Python at the same time. So it's like, why wouldn't you do it? Now it's going to go through each one of these and notice how we say set up Python here. And let me just refresh this. If we say, set up Python, it says successfully set up Python 3.6.2, display Python version, and look, it even tells us exactly the Python version and even when it was built, because we put that command in there. And then I go through and I install the dependencies, I lint. So everything's working successfully. And so probably the other thing that I would do would be to click on this this 3 button bar here, and I'll copy that, and then I'll go to the section here and put in this into the badge. So basically now I have a badge set up here that set things up. So in a very short amount of time, we have an extremely sophisticated multi-Python testing system. So I guess the other thing that we could do before we get into the multi-cloud part is, why don't we just read through the documentation and see that so it also says it supports PyPy2 and PyPy3, and that does look kind of interesting. So maybe we could also throw in one of those as well. And I don't see let's see, PyPy. Let's see here. So the PyPy, if you're not familiar with it, is actually a version of Python that's a Python on Python compiler. And let's just see if I can find one real quick and see if we can throw one in. If we can, that's great. It's not a big deal if we can't. And let's see if we see one here. So PyPy3 is now the latest version. Okay, I think we just put PyPy3 in there, but let's try it out. We can just go back to GitHub Actions here and then try this. Let's try this, PyPy3. I'm guessing this would work. So I'm gonna say git status, git add this, and see if that is in fact the way you do it. Adding PyPy3. So again, the PyPy3 just shows if you were, let's just do git pull. It was the badge. Okay, that's good. We'll just close this file here and then push. So let's go now and take a look and see if this build is able to get a 4th build, maybe. If we're lucky, I got it to work. Okay, well that's kind of cool. Yeah, the PyPy, it's a Python on Python compiler. I don't have a ton of experience with it, but I know that some people like it, and it is a way to speed up your code. So again, what's kind of cool about this is that if we say display Python version here, is that now I'm able to test my code out in multiple unique and bespoke versions of Python, including some fairly exotic ones like this PyPy3 version here. So again, if I go through here and I say, display Python version, we see that in fact it's running PyPy 7.3.3 with GCC 7.3.1 on Red Hat version 3.6.1.2. So now what's interesting is it just caught a bug for us, right? And so this is one of the benefits of using something like PyPy inside of the GitHub Actions, is there's some kind of a problem with some library, and it looks like it's probably this. Let's see where it fails. it looks like it blows up. It blows up installing maybe Python Black, I think. But it essentially did exactly what we intended it to do, which is we know that all of our packages work on these languages, but this more exotic version of Python, we found out there's an issue, which is probably not surprising for people that use this particular library. So I guess I could try to debug this thing. I think it is potentially Python Black because that's the last thing I see. So let's go ahead and double check. So if I go back here, let's just remove that from our project. So let's go back to GitHub Actions and let's just take out that last step, which is, or actually let's take out the Python Black temporarily in the requirements file. That's the one that I would suspect because it's a fairly new library. And then I will again commit this, so git status, add this, and we can test it out. Removing Black. Okay, we go ahead and push this code. We go back here and we test it out. So this would be exactly the kind of workflow if you're a professional Python developer who's doing, let's say, libraries for a company. You're working at a software as a service company, and let's say you have a Python package that you build that people use. This is exactly my recommendation of how you would work through it. Is you would take the most common versions of Python and you would put them all into a build like this. And if you're lucky, potentially you would everything would just work. Now, notice that it's failing at a different place here because we have the format code here. And so what I want to see was I correct in where it failed. So I was incorrect. So there's something else that it's failing on in this particular. It's still failing on something. So there's some dependency that doesn't work on PyPy 3, which is fine. So I'll just go back here and put Python Black back in and do that. There we go. And if I say git status, git add, git commit, adding Python Black back. And so we know that we could just put a note here that says, there's some of the libraries that we need aren't supported with that exotic version, which again is not a surprise here for us at all. So that's really in a nutshell, the benefit of something like this web-based code editor plus GitHub Actions is that it can discover things like that. It can discover that there's a particular version of what we're doing that doesn't work with that, which is totally fine. Now let's move to the next section here, which is that now that we've got this GitHub Actions and Codespace thing working, and we know that it works on 3 versions of Python, what we can do next is actually get into the cloud environment. So let's just start one by one. Let's start with the biggest cloud environment first, which is AWS. So in AWS, I would say that Cloud9 is the way to go. And with Cloud9, to set it up if you're not familiar with it, you can either create a new environment if you don't have one, or you can use an existing one. Just so that I show everyone how to do this, let's go ahead and create a new environment, and we'll call this advanced testing here, and just say this is an environment for advanced testing. Okay, so let's go through here, go to the next step. Now, a couple of things to point out here is that by default, you most likely would want to just create a new Ec2 instance for your environment. And probably the micro is good enough for you as well, because it's free tier eligible. But if you do want to get into doing some really complicated prototyping like GPUs or parallel computing or something like that, then you do have the option of going to some pretty large systems here. Like, for example, I have a very powerful machine at home. I have 300 gigs of RAM and 32 cores, but on my Mac, but this one has more. This one has even more RAM. So if I want to do something exotic, I could actually play around with this. I'm going to just pick a T2 Micro. Then the other thing that's interesting is you can either do Amazon Linux. I would say for most projects, Amazon Linux is probably the way to go because of the fact that you're going to get access to all of the same kind of tools that are available in your development environment. But you could, if you wanted to, make things a little bit more exotic and use Ubuntu Server just for fun. Since we're testing Ubuntu Server on the GitHub Actions environment, I'm going to go ahead and select that, and then I'm going to go ahead and say next. Actually, you know what I'm going to do as well, though? I'm going to go back here and just I'll say advanced testing and just say Ubuntu Server, right? So I know that it's an Ubuntu server. Okay, let's go through here and say next, Ubuntu Server. Great. So this usually takes like probably 60 seconds or so to spin this up. And the first thing that I'll need to do is that I would need to go through here and check out the repo and add add basically the SSH keys. So I can basically get that set up ahead of time by going to open up a new tab here. Let's just open up a new tab. Move this over. We'll just say GitHub. And you will need to go to your profile here and then go to, go to settings and then go to SSH and GPG keys, create a new one, and we'll call this AWS Ubuntu. And hopefully it's already up, or there we go. Yeah, it's waking up now. And once this is completely woken up, then I can create new SSH keys and put them into GitHub. So let's go ahead and do that. Okay, SSH keygen -t RSA. All right, and we'll just look at that file, which is right here, like that. Okay, great. That's in there. I'm going to grab that file here and just throw that into this section. It'll ask for a password. Okay, so now that I got that set up, I can go back to this particular repo and just check it out. So I'll just say code and make sure it says SSH, copy this to this particular environment. Okay, and we'll do git clone. All right, and once we get this set up here, I'll do the same thing. So notice if I just type in Python 3, it's running Python 3.6.9, and I can do the same thing. I'll use I believe Python 3, does it come with a virtual environment? Yeah, so we'll say virtual environment. I'll say tilde. We'll call this CLI multi-cloud. There we go. I'll source this environment, and then I'll do the same thing that I did earlier, which is I'll test my code to make sure things work. Bin activate. Okay, and we can just say cd into that directory now, and I can just say make install. So this should, in theory, all work because we've already tested it from GitHub, which is again one of the benefits of doing something like this. And looks like it's all working. Perfect. Now that we got this set up here, I can do make lints. That works. Make test. That works. Right. So this is really the benefit of testing is I have this system in the cloud with GitHub Actions just going through and testing all these different variants, so I know it's going to work when I come here locally. So now I can just go through here and say Python, hello, search for files, and I can say, or actually let's actually change this because it's slightly a spurious message. It's not just CSV files, I believe. It says path to search for we'll call this for patterns, for file patterns, like that. And so if I go back here and I say, I think it actually, maybe I'll chmod this as well. I'll just say chmod plus x, hello. And then I'll just do this. I'll say hello, so path to search for file patterns, and we'll just say, .py. Oh, actually, we'll say path to search, we'll say dot type of file py. There we go. So found two matches. So we've got something that's somewhat useful here, and then I can go through and I can push those changes. There we go. And commit this, adding these changes that fix the message. Push, and then notice that I have to do this setup here because I have a new git checkout, and so I just do it this way. I just fill in the blanks. I believe that GitHub itself has they automatically do this for you in Codespaces, which is kind of nice, unless I wasn't paying attention to the messages. All this does is just make sure that the commits are normal commits. Okay, and git commit. That's funny that it won't. Please. Okay, so we'll do -m. Git commit -m. Let's try that. Anyway, it's not important. We can just push this. So inside of here again, I can now go back and we can see that the changes that I did inside of Ubuntu now, which is similar. It's basically this environment here is very similar to what I just was working on inside of the AWS cloud. And in fact, what we could do to just double check this is if I type in uname-a, this shows me the exact version of Ubuntu, right? It says Ubuntu 18.04, all this stuff. So what I could do is, why don't I just do that? Why don't I go to my my GitHub Actions here, file, and let's just actually add a little more smarts to this that will allow us to see what particular version of Linux we're running, which can be very helpful. So what I'm going to do is I'm going to add another step here that says, and let me just make this a little bit bigger, and I'm going to add a step that says let's also show the version of Linux, because we could be Linux core developers and we want to know what's going on. So let's go through here and just say this uname-a, and so this will just print out inside of the build process the version of Linux. So there's a lot to like about this GitHub Actions workflow because of how much awesome power it gives us to do things like this, right? And so now if I do a git status and I say git add, and we'll add this in here, we can go through here and adding a change for GitHub that allows Linux versions to be printed. Okay, Let's go ahead and push that. And now if we go back to GitHub Actions here, we have some additional smarts. We now can look inside of the build process, and not only will it show us the installation, it'll show us the testing, the linting, all this stuff. It will also show us the version of Linux, and so we can actually see how similar things are. So here we go, display Linux version. If I go here, you have to kind of refresh this. It's a little bit laggy, but basically we'll let it finish. Okay, so go here, display Linux version. So this one says it's running 1804 as well, right? So it's 1804.1, and then if I go here and I say uname-a, we can see that's 1804.1 as well. So pretty awesome, actually, that that I can do an apples to apples test here. So not only am I testing the version of Python, but I'm also testing a version of Linux as well. So let's keep going. And one of the things that we can do is now do the same thing on the Google Cloud next here. So here's the Google Cloud Platform. If I select this icon called Activate Cloud Shell, one of the things I can do is click on this right here, say Activate Cloud Shell, and it will allow me to do something similar. So I believe I've already created the SSH keys in this environment, so I don't have to do it again. All I need to do is clone this. So I'm going to go to, again, this CLI multi-cloud, click on this icon, and then do git clone. Git clone, there you go. Make this a little bit bigger. Great, so we've got this environment set up here. And in particular, I can do the same thing. I can do virtual environment. Let's make this a little bit bigger. Virtual environment, and we'll say tilde/.cli multi-cloud. We'll source it, source tilde/.cli multi-cloud bin activate, and I should be able to change into that directory, do the same thing. Say, in fact, since I keep doing the same thing, which is make install, make lint, let's actually simplify life a little bit. I'm going to go open editor here because it has a built-in cloud editor. And what I'm going to do is add a step in our makefile. So let's go here and add a step here for CLI multi-cloud. And let's add an all. So what this all one will do is this. I don't know what that is, but I don't care. We'll say all, and then what all will do is install lint and test, just like this. So let's go ahead and try that out. Go back to the terminal and say make all. And what's nice about that is that then it's even easier for me when I first get on a system to basically go through and test things out. Great. So this thing looks like it's working. We've got 91% test coverage. Perfect. So let's put that change in there. So let's go ahead and say git add makefile, adding the changes, and push this. Okay, so we got this thing pushed to our location, and I can go next now and look again at GitHub Actions here and see what's cooking. So we've got this here. That's our change, and if I look at the change here, we looks like it's so far successful. Great, and everything's working now. I'm assuming there'll be no problems with just that makefile change. Great, everything looks like it tested, formatted, perfect. So what we can do as well is let's just look at this version of Ubuntu, uname-a. So this one is running kind of an exotic version of a container, and I don't even know what that is. So I think it's some kind of customized container that Google Cloud Shell is running. In theory, we could try to figure out how to run this inside of GitHub Actions, and there might be a way to do it as well if we wanted to kind of go that route. But